So we have created our first Hello World program, and it works printing using the TP write instruction to write Hello World to our pendant. And now we'd like to do something a little bit more sophisticated. We would like to also record the amount of times that we write this to the teach pendant. In order to do that, we need to have a number that records the amount of times we have written to it. So we're going to create our first variable called, and we're going to start it with var for variable, and it's a number that we're trying to record. So we're going to say num, it's a type of num, and we're going to call this a var part counter. Ooh, how about just var counter? Variable counter. Okay. So we have declared a variable counter. There are some naming schemes that you have to take in consideration when you're creating variables. They have to start with a character. They can't start with underscore, otherwise you're going to get an error. They can't start with a digit. They can't start with a period. It has to be a character. Doesn't matter if it's uppercase or lowercase. And then anything can follow. So then now we can do var counter 1 or any other alphanumeric value. So, and you can continue from there. But we have our var counter, and we're going to want to increment this counter as we continue through. So we're going to say var counter equals var counter plus 1, and apply those changes. Now we need to test our program. If we hover over this, we can see that var counter equals 0. So we're going to put our program pointer to main, step, 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 and now we can see, hey look, var counter right here is now at 1 instead of at the 0 that it began. So it looks like we're counting properly. We're going to continue playing through second time, and look, we're playing it through twice. Perfect. And third time's the charm. Yep, it's counting to 3. So this looks like it's working just fine. But there's one consideration that you need to know about when programming with VARs, is that if there's ever an error that's encountered, it's going to destroy the value stored for VAR and reset it to its default value. So for nums, it's going to store those as zeros if it gets reset. If it's a Boolean, it's going to go to false. If it's a string, it's going to get set to empty. So in this case, if we right-click and we do pp to main, which is going to simulate that error, we can re-hover over our counter and we can see that it got reset to 0. So how do we counteract this? Well, instead of declaring it as var, we can have a different type, persist for persistent, PERS, and we're going to create this as a PERS counter, and then we're going to set it to 0, apply, and now we're going to incorporate this into our code. Persistent counter equals persistent counter plus 1, apply. Now we're going to go over here, pp to routine, and we're going to step over, boom, 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 go through this, and we can actually see that persistent counter started at 0, just like that. We've both incremented both of these counters. Persistent is now happily updated this sheet, so that looks really nice. We can continue playing through, and now everything's been up to value 2. And then we go through a third time, because third time's the charm, and now we're at 3. So this is where we were before. Now we're going to simulate that error again and set program pointer to main. And now we should see var has lost its value. It was at 3. It got reset to 0. Persistent counter, though, has retained its value, and it's now still at 3. So if we continue stepping through, now we can see var is at 1 and persistent counter is at 4. So persistent numbers maintain. And sometimes when you reset, a var counter will get reset It depends on whether your program pointer is destroyed or not. But a persistent value will maintain its value even after a reset or an error. So why would you ever use a VAR versus a persistent? Sometimes it is nice to reset something. Like, let's say we have a timer. We want the timer to automatically reset whenever we have an error. Well, in that case, we would probably create it as a VAR. Or maybe you're trying to keep track of something and then some error occurs. We want to be able to automatically clear it. Another advantage of VAR is it takes almost no memory to store a VAR versus a persistent. It takes a little bit more time for it to update, and it takes a lot more memory associated with it. It's a lot more work for the robot to work with persistence. So you kind of keep those in mind. There's one other type of number that we have not looked at though, or another declaration type, and that is const. Const. And we're going to have a num, constants, counter. Oh, excuse me. Equals 5. Okay? Apply. Constants cannot be changed. So if we try to write our code like what we did for the other ones, where we have constant counter equals constant counter plus 1, and we apply these changes, it's going to give us an error. And if I bring this down, we can see in this output pane, it tells us about errors. Right here, error. You have an error on line 12, character spot 9. Line 12, number 9. You cannot assign, assignment is read only. So right there, it's saying, hey, this is not valid. Why would you want a number constant? Well, maybe you're creating an ID for a gun, or you're creating a message. The message should never change, so it's nice to declare those messages as constants. So we're going to comment this guy out. We get rid of him, pretend like he never existed, and then our program is fine.